Hatter, and I'm here to explain the features that changed in Structura 1.3. This update is mostly a back-end update, but there are some interesting changes for many of you along the way. So, what changed? First, Structura was rewritten to be data-driven. Data-driven means that it's now possible to update and add new supported blocks without rewriting all of the Python code. This is not always true, but in most cases, the blocks can be updated by users like you. Second, support for several blocks was added. This includes end rods, torches, glass panes, repeaters, including the tick settings, comparators, including the inversion state, levers, and buttons. Some of them will be supported in ways that you really wanted, and others it'll be slightly better but not perfect. Now, for those of you who want to help out and add support for a block, I'm working on a written document, which hopefully will be linked in the description, but this video will go through some of those as well. So, first thing is you're going to need a text editor like Notepad++, an image editor like GIMP, and optionally you can have an NBT data reader, such as NBT Studio. Links for those will be in the description. The NBT reader is optional. It helps you read what's going on in the block states rather than just guess and check, but you can get by without it if you can't get it working. Now, the first thing you need to do is generate a structure file with the block that you want to fix. If you're going to actually use NBT editor, I recommend putting one block in the first structure so you can understand how the NBT data is organized. I'm not going to go through how the NBT data is organized in this video, but it's documented in the wiki, and I'll post a link to that article in the description. Now that you have a structure containing the block that you want to fix, we need to look in the block definitions.json in the lookups folder for the block name. After we find the block name, you're going to find a common name. What this means is blocks that are very similar to this block will share the same settings. So one good example is glazed terracotta. Glazed terracotta has a lot of variants, but they all use the same block definition for rotations, etc. In my case, for this example, we're going to use the repeater, and it's going to have two different block names, repeater powered and repeater unpowered. And I'm going to make them common. I'm going to have one block type that is just repeater. I'm not going to handle on or off, so that's just future work that somebody else, if they want to, can support. In Minecraft, everything is rectangular prisms, so when looking at a block to support, we need to break it down into the fewest number of rectangular prisms. So if we look at the repeater, there are three individual components. There's the flat base and the two redstone torches. So we know that we'll need 3 bones for this block. Where we will find those bones located is in the blockshapes.json. So if we open that up, we can find the repeater block, or we can add one if we made a new name. So in the repeater block, we're going to have a size and an offset. Because there are 3 blocks in the repeater, the base and the 2 torches, we'll need to make 3 different sizes in an array, and I'll show you that on screen now. And then we're going to need to make 3 offsets in an array, and I'll show you that on screen now. Now, because the offsets are shifting with each block state, we need to start defining the block states for the ticks. So the way that this works is in the JSON object, if you're looking through the code, there'll be states 0, 1, 2, and 3. So we need to define the different block shapes, sizes, and offsets for each of these states. And this is a lot of copy-paste. So for size 0, we have one set of offsets with the same sizes. For size 1, we have a slightly larger offset on the last torch. I'm going to put all of the individual block states that I developed for this on screen now. Now we know the block shapes, but the block shapes will have incorrect textures. So we're going to go to the blocks underscore uv.json file, and again, we're going to search for the repeater object. If it doesn't exist, we would add one. And in this object, there are two things that are required and one thing that is optional. The two required things are the size of the portion of the texture that we want to use and the location we want to use inside the texture. The optional thing is the overwrite to define a texture that is not the default texture chosen by Minecraft. This is really useful with these complex blocks like repeaters, but it's not required for every single block. Many things like hay bales and terracotta again will not require any sort of overwrites. So you don't have to have the overwrite section. So to start with, the UV sizes have to be the exact same length as the number of shapes you chose. So in this case, we have the base, the torch, and the other torch. So let me drop you on screen now an example of the UV sizes used for the repeater. If you look closely, you'll see that the size for the first one is 1 by 1. You'll notice that this is for the up direction. In all of the blocks, you get a up, down, north, south, east, and west side, and they can all be different. So we'll have to define all of those for all the blocks you want to support. You see that in here, we have the UV sizes for the torches, which are much smaller. These sizes are actually the percentage of the picture that are taken up by the pixels we want to color with. So these will vary depending on the size and shape of the block and the texture file used. Note that this is a percentage of the 16 by 16 image, so you can work through that accordingly on your own. The next thing that we need to do is set the offset. This starts in the upper left-hand corner and goes to the bottom right-hand corner of the image. So opening up an image and counting the number of pixels will help you find the percentage offset that you need. If you're using the full image, then 0, 0 is the appropriate offset. If you're using a small section in the image, you need to choose the correct portion of the UV by selecting various percentage offsets. This is kind of a guess and check as well. You'll see that things show up correctly or not correctly as you get the UV in the right spot. Finally, in the case of the repeater, we need to find overwrites. The overwrites are the ability to choose a different texture file. The different texture files are just simply put in as their path. So if you choose default, it's not going to choose a random texture file. It's just going to go with what Minecraft would normally use for that block. For some of the parts, you're going to need to find a custom texture. For this case, we're choosing the redstone off texture. So we have to navigate to that in the default behavior pack. And that's in the textures blocks redstone torch off. Don't include the .png. The Structura program will add that automatically. It's just the way that it works inside of the program. So now we need to repeat that process for each block state and each side. Once you're done, you'll have one block that looks good in one direction. So the last step we need to do is define the block rotations.json. So this one, I would recommend going into NBT Studio and looking for the rotation field. These rotation fields kind of are a little silly. Some of them are pillar rotations, some of them, it gets kind of messy, so you're going to have to do this on a block by block basis. So now we'll take the number of block rotations possible and we'll index them out, 0, 1, 2, 3, 4, up till the end of the possible block rotations. Then we define rotations on the 3 axes, X, Y, and Z. You can think of this like spinning it on a top, and the axis that you're spinning along is either X, Y, or Z. So here's an example for the repeater. It's a simple one. Now run all of your JSON files through a JSON checker. There will be a link in the description to one that I use. And if you don't, Structura will crash, so you get a little frustrated. Now you may ask, how have I done all of these block fixes so far? And Unfortunately, I'm going to tell you, it's all guess and check. Fixing a block usually takes me around 10 to 20 tries. I make the file 10 to 20 times, load it into Structura, load it into Minecraft, and see how it looks. If you choose to fix a block, please, please, please give back to the community and help us fix that block for everybody else. You can do this by putting in a git pull request. If you don't know how to do that, I will do it for you if you post your changes in my Discord. All you need to do is go to Discord, accept the rules, and post your changes in Structura talk. I will figure out what your changes are, I will test them, and I will put them into the next release. So what's coming next? In Structura 1.3, we rewrote the entire Structura to make it easy to update. In Structura 1.4, I plan on merging the support that Programmer has done to make it flexible for other systems other than Windows. I also plan on adding an update feature that allows for the program to search for updates to the block definition, so you don't have to download a new version every time we change one block, and a few other minor things. So with that, I think I'm done. So this is Structura 1.3. Thank you for watching. And this is Hatter. I'm out. Bye.